Earth's atmosphere is a dynamic system. Its composition depends on fluxes of material from the Earth due to tectonic activity and chemical processes such as rock weathering and photosynthesis. The three dominant gases in the atmosphere are molecular nitrogen, molecular oxygen, and the noble gas argon. These three gases alone make up over 99% of the gas in the atmosphere. This was not always the case. Prior to the widespread production of oxygen through photosynthesis, the dominant gases were nitrogen, carbon dioxide, and methane, along with water vapor. Diatomic oxygen is very reactive, and when photosynthesis first arose about 3.5 billion years ago, all of the oxygen produced quickly reacted with things such as dissolved iron in the oceans. Molecular oxygen did not start accumulating in the atmosphere until about 2.5 billion years ago, as the amount produced by photosynthesis began to exceed the amount of iron and other reducing compounds available for oxygen to react with. The fact that oxygen is now the second most abundant gas in the atmosphere is a testament to just how dramatically life has transformed planet Earth. The balance of the atmosphere is made up of a number of trace gases present at low concentration. The most abundant trace gas is carbon dioxide, along with inert gases neon and helium. There are also lower concentrations of methane, nitrous oxide, which is a byproduct of the use of fossil fuels for transportation and the production of industrial fertilizer, and ozone, which is concentrated in the stratosphere and is produced naturally through the interactions between solar radiation and molecular oxygen. There is also a significant amount of water vapor in the atmosphere, with concentrations ranging from 0 to as much as 4%. Water vapor is treated separately because of how much the concentration varies over space and time. Some of the trace gases have low overall concentrations, but they play an essential role in maintaining our climate due to their contribution to the greenhouse effect. The greenhouse effect is driven by the fact that our atmosphere is transparent to a wide swath of the sun's electromagnetic energy around the visible range. This energy makes it through the atmosphere and is absorbed by the ground. The ground then re-radiates it as long wavelength infrared energy. While the major components of the atmosphere, oxygen, nitrogen, and the noble gases, do not absorb energy in the infrared range, some of the trace gases, including carbon dioxide, methane, nitrous oxide, and water vapor, do absorb energy in these wavelengths. So the presence of these so-called greenhouse gases captures some of the energy radiating from the ground, preventing it from passing right through the atmosphere and back out into space. The greenhouse effect is natural, and the presence of these greenhouse gases is what keeps our atmosphere warm enough to allow liquid water to exist on the surface of the Earth and provides an environment conducive for life. The actual temperature is dependent on the concentration of these gases, and any change will alter the flux of energy through the system and result in a change in the global energy balance. An increase in the concentration of these gases will cause more of this infrared energy to be trapped as it moves from the surface of the Earth towards space, causing an increase in temperature. This is the basis for our concern about global warming. Industrial activity such as the burning of fossil fuels and the use of large quantities of artificial fertilizer have increased the concentration of these naturally occurring greenhouse gases, trapping more energy and warming the Earth. In addition to changes in the concentration of naturally occurring greenhouse gases, humans also release large quantities of man-made compounds into the atmosphere, and some of these, including chlorofluorocarbons, are potent greenhouse gases in their own right. These chlorofluorocarbons also have a negative effect on the ozone concentrations, but these effects are separate from chlorofluorocarbons' role as greenhouse gases.